So in this video, I'm going to introduce you the induction and charging by induction. Induction. Sorry. So induction is you see in a conductor. What does conductor have that insulator material don't have? Free electrons. Electrons are free to move inside the conductor. So when you have a conductive material, let's say I bring this, it could be positive or minus negative, but let's say this is a positively charged object. Positively charged rod that I'm going to bring nearby. And here is a neutral, electrically neutral, and conductive material. It could be metal. So let's say we have a plus and minuses, right? And then I bring this closer. Then what happens if I bring it closer? There are free electrons inside this conductor, right? Free electrons means that these electrons are free to move. So when you have a positively charged object coming closer, the negative will be attracted to the positive. At the same time, the positive will feel repulsive force that goes to the other side. So as an overall, this object is still neutral. But charges are induced. Which means that charges are separated at two ends, two opposite ends. So this is called induction, that you induce the charge. So overall it's still neutral, but you have a minus on one side and a positive on one side. So what happened to if this piece of a metal might be very, very light, then it may get attracted and it goes in. So that's what we see here, right? In demonstration. Here, you put the charged straw nearby. This can that's made of metal, so the charge will be induced. So if this is positively charged, minus will come here. Positive will go there. So it moves towards it and moves towards it. So in this case, we saw the charges are induced. we can actually charge it by using this induction. So charging by induction. So again, now this could be negative or positive, but I could have a negatively charged rod. And then here, nice. I have a two neutral metallic balls in contact initially. So they are attached. If I bring this bar closer, to the metallic ball, then you see that initially it's neutral, but positive will be attracted to the minus. At the same time, negative will be repulsed to the other side. So then, while I don't need to touch it, no touch, just close by. Then it's still we want to keep it closer. Then we're going to separate this too. So then I'm going to separate these two now. So while having a rod nearby, I'm going to separate these two. So minuses, pluses, still here, minuses is still here. But now we separate. Physically separate them, then remove the rod. What happens to the one rod will be positively charged. The other one will be negatively charged. So we use the induction and then we physically separate them. Then one of object will be positively charged and negatively charged. So this is charging by induction. What happens if I make a contact? I could do it before that. I could do it differently too. So here, let's say I have a ball, right? And again, this is neutral. And I bring a rod. Again, it could be negative or positive nearby. Bring it closer. Then what happens? Then what happens to this metal ball? We're going to have again the positive will be attracted on one side and negative will be on the other side. Then, right, I'm going to touch the other side. What happens when I touch it? If I touch it, then this negatives doesn't do it. I see. These negative will start going into, it moves out from one side. So because the hand is a conductor, so this negative will flow into the hand and then through you go to the ground. So at the end, this ball will be what? What's charged? What is it positively charged, negatively charged, or neutral? Positively charged. It loses the negative and then becomes positively charged. So you can touch the one end. You use the induction and then touch the one end and it becomes that charge. All right, so this is charging by induction.